Hello and welcome to today's video, which is about random sampling, which is a branch of statistics. So firstly, what is random sampling? Many times we want to know about something, but it's not possible to ask everybody. So for example, a teacher wants to know if students like the school uniform. She could ask every student, but that would take a long time and a lot of work. It would take a long time to read all the answers and work out what most students' opinion was. What if, instead of asking all of them, she only asked some of them? Would she get the same answer as if she'd asked them all? And the answer to that is maybe yes, maybe no. So let's say there are 900 students. If she asks 899 of them, but one person wasn't asked, do you think she would get the right answer? Probably yes. The chance that the other person had an opinion so different from the rest of the 899 students for it to change the result is very, very small. What if instead of asking all of them, she asked only one? Would she get the same answer as if she'd asked all of them? And again, the answer is maybe yes, maybe no. One is a very small number, but there is still a chance that it would give the same answer as the other students. It might depend on the question. If it was a question that most people agree about, like, do you think Justin Bieber has a better voice than your teacher? It's likely that you would get the same answer from one student as you would get from most of the 900 students. If the question was, what is your favorite color? The chance that the answer would be the same as the rest of the 899 students is small. So this method of not asking everyone, but just asking a smaller number of people is called sampling. The words sample and example are very similar. An example is a story to help the reader or the listener or the viewer understand something. A sample is when you take a small amount of the thing that you want to find out about and use it to check out what all of the thing is like. It's not just statistics. When you go to the market and one of the sellers of oranges has cut open some oranges so that the buyers can see that they are good oranges, the orange that he's cut open is a sample. There are lots of things that can go wrong with samples, and we will look at them later. But for now, let's just say that if it's done right, sampling is a good way to save a lot of time and energy if you want to find out something in a situation where you cannot check everything one by one, and the answer doesn't have to be 100% accurate. So we're going to look at some of the uses of sampling. Businesses often use sampling to find out if people are happy with what they are selling or not. If the makers of Birdie want to find out if their customers like a new taste, they would do a survey to find out their customers' opinion. They might ask two multiple choice questions. Do you ever drink Birdie? Yes or no? Do you like our new taste? Yes, no, or never tried it. The first question is because many of the people they ask will not be Birdie drinkers, so they don't want to include them in the answers. After they look at the results, they should be able to say X% of the people who have tried our new taste like it, and Y% don't like it. They can use the information from their survey to help them with their business. If a lot of people don't like it, they will know that they need to change it. If most people like it, they will know they're doing it right. If most people have never tried it, even ones who already drink Birdie, they will know that they have to advertise it more. The next group is politicians. Politicians use sampling to find out what people want them to do and if their ideas are popular or not. Government departments use it to find out what is happening with things they control. For example, the Thai Immigration Department, which is part of the Thai government, might do a survey to find out how long people have to wait at their offices. They don't want to ask everybody because that would cause a lot of work asking them and then more work checking out what the results showed. So they might ask only 10% of the people, or they might do it for just one day. Bias. Random and bias in samples. Suppose the choice of people you got to answer the survey was biased. Let's say you only asked boys about the school uniform, or you only asked people under 30 about Birdie, or you only asked Rohingya people if they agreed with Aung San Suu Kyi's ideas. What would happen? The answer the survey gave you might be wrong. If you only ask the boys about the school uniform, you might never find out that the girls don't like their skirts. If you only ask under 30-year-old people about Birdie, you might never find out that old people really like the new taste. And if you ask only Rohingya people about Aung San Suu Kyi, you might never find out that a lot of Burman people like her ideas. So how do we avoid these kind of problems? And the answer is random sampling. Random means that no one controls who is included in the sample. It's left to chance or luck. Think about when we have a fundraiser at school where you have to buy a ticket to win a computer. How do we decide who will be the winner? And the answer is that usually we have a drawer on stage where all the tickets go into a container and someone we can trust pulls out the winning ticket. This is a random choice. No one controls what the answer will be. With random, it is often not only that the choice is random, but that people can see that it's random. It's very easy to get a computer to choose a random ticket number from all the tickets that have been sold. But it's also easy for the computer programmer or the operator to cheat. That's why people like low-tech ways like putting all the tickets in a container and pulling out the winner's ticket. Not because the computer can't do it, but because you can see with your own eyes that it is being done fairly. How would you feel if there was just a notice one day to say that Nonananu was the winner? Maybe you would be a bit suspicious that she had been chosen because she was a friend of the organizer or something like that. In many situations like this, the winner is selected on TV so that everyone can see that there is no bias. Okay, your turn. So Tutu put some cards into a basket and then he drew 3 cards out of the basket. Is this a random sample of the cards in the basket? And why or why not? So I'm going to go straight on to the answers. So pause the video if you need to. Here we go. And the answer is yes, it is random because he does not control which card will be chosen. So Name Your Shine wanted to know what was the most popular shoe brand of his classmates. He asked 10 boys the brand of shoes that they were wearing. Nike was the most popular brand. Can you see any way that So Name Your Shine sample was biased? And I'm going on to the answer now. Here we go. And the answer is he only asked boys. So he should have asked girls as well. And he also only asked about the shoes they were wearing today. So if, for example, they knew their shoes would get dirty today, maybe they were not wearing their favorites today. So it's possible that it was biased. Sometimes the bias is not obvious and maybe it doesn't exist, but there is the possibility that it exists, so we cannot be sure the sample is random. Let's ask that last question again, but with some changes. So Name Your Shine wanted to know what was the most popular shoe brand of his classmates. He asked the 10 people sitting nearest to him in class the brand of the shoes that they were wearing. Nike was the most popular brand. Can you see any way that So Name Your Shine's sample was biased? So let's go straight to the answer. And maybe the people who sit near So Name Your Shine are his friends, so they dress the same way as him. Maybe he's sitting with the boys so the girls don't get asked as much. Maybe he's sitting at the front with the clever students or at the back with the not so clever students, so that causes bias. None of these things is sure, but they are enough to create a worry that it's not random. So, summary so far: sampling is a way to find out about something by only asking or looking at a small part, not everyone or everything. And this can save a lot of time and energy. Samples should be random. There's a real danger that samples will be biased, and sometimes the bias is easy to see, but sometimes even the person who chooses the sample will not be aware of the bias. Making sure there is no bias in surveys is very important. If bias is present, the answers given by the survey may be completely wrong. Clearly, how big the sample is important. If there are 100 in the group, a sample of 99 will be more accurate than a sample of 1. So how big a sample do we need to be accurate? There is no easy rule. Mathematicians have worked out the chances of a survey being wrong, but it's complicated and it depends on how confident you need to be that the answer is right. It's normal to write a margin of error next to the result. So, for example, 55% of people that we asked said they were happy with the President of the USA. And then they say 3% margin of error. 3% margin of error means it could be up to 3% higher or 3% lower. What they're saying is we think the answer is 55%, but it could be anywhere between 52%, which is 3% lower, or 58%, which is 3% higher. Okay, your turn again. 80% of people prefer Coca-Cola to Big Cola, with a 5% margin of error. What are the highest and lowest possible percentages? And I'm going to go ahead with the answer now. And the highest one is 85%, which is 5% higher than 80, and the lowest one is 75%, which is 5% lower. Big question, did you get them the right way round? If the question asks highest and lowest, you must put the highest first. Okay, some uses for sampling. Businesses and political uses versus academic uses. For political uses, a low level of accuracy is widely accepted, and the surveys often get the wrong answer. So, for example, a survey result might say Kamala Harris was ahead of Donald Trump in the presidential election of 2024 by 2%. Margin of error 5%. Sample size 1,000. This is saying that Harris could be anywhere from 3% behind Trump to 7% ahead. The sample size is also extremely low, 1,000 people out of all the people who are allowed to vote in the USA. Low accuracy, low sample sizes are frequent in politics. The surveys have a very short life because people change their minds a lot in elections, and probably there will be another survey within about 2 days. So in this situation, no one wants to spend a lot of money on a very accurate survey. For business, it is more important to get an accurate answer. In the earlier question about Birdie, the business is going to make important decisions based on the survey. Nevertheless, the business probably doesn't want a super accurate survey, because firstly, the more accurate, the more it costs to do the survey and to analyze it. Secondly, if they change something because of what the first survey shows, like maybe they decide to advertise more, the old survey will be useless very quickly. For academic use, a high level of accuracy is expected, but often the sample size, and therefore the accuracy, depends on who the findings are applied to. So this is a made-up example, but it's fairly typical. So a professor of some university has just shown that students who are hungry when they come to class learn less than students who are not hungry. And they give us the information. This experiment was conducted with 5,000 students in New York. What do you think about the accuracy of this result? There are 1.1 million students in New York's public school system. So do you think 5,000 is a big enough sample size? Another way to put this is to say we did this experiment with 1 out of every 220 students. In the whole of the USA, the number of public school students is 56.6 million. 5,000 is a sample size of 1 out of 11,320. In the world, there are approximately 2 billion people under the age of 14. Some will be too young for school, but many students also stay after the age of 14. So what do you think of a sample size of 5,000 out of 2 billion? Or in other words, 1 out of every 400,000 students. You can see that while a piece of research may be carried out with great care, we have to be very careful about thinking that its findings can be applied to a very wide audience. Many factors like culture, diet patterns, and content of the diets may also influence whether this example applies in other parts of the world. However, it also shows that the sample size alone is ridiculously small to apply the conclusions to all the schools in the world. So the conclusion is academic research using results from a small sample of people can only be applied on a very limited basis. And sometimes people don't like to give the correct answer. So you ask them a survey, they have some reason not to give you the right answer. Maybe they just want to keep the information secret, so they'll tell you something that's not true. Maybe they are ashamed to tell the truth, if the question is a very personal one. So here are some questions that people often don't tell the truth about. How old are you? How often do you lie to your mother? Have you ever stolen anything? Tell me about your ex. How often do you fall asleep in class? Have you ever promised your boss something but you didn't do it? Have you ever told someone you agreed with them when you didn't? How many kilos are you? So people often want to keep some of this information secret. So let's talk about the limitations of random sampling. Non-random sampling can be called controlled sampling. The idea is still about sampling. You are still questioning a smaller number of people to find out what a bigger group would do. So, example, we want to find out what people in your village would do if they received a gift of 100 baht. So if we pick random people, we have no idea who will be picked. Even if we picked a big sample size, like 33%, how certain could we be that the people who were picked accurately reflected what people in your village would do with an extra 100 baht? The test is this question. If I did the test twice on two groups, and both groups were picked randomly, would I get the same or very similar result? Why is this question important? Suppose I did the test 2 times. Each time the sample was 33% of the number in the group, so the sample size should not be a problem. According to the theory, the 2 results should be the same or very close within the margin of error. If they're not the same, there's a problem. Because we have 2 different answers to the question, and we don't know which one is right, or even if either one is right. Maybe if we did the survey one more time, we would get a 3rd different answer. So, for example, let us say there are only 6 people in your village. 2 are young, 2 are middle-aged, and 2 are old. The young people would spend the extra 100 baht on clothes. The middle-aged people would spend the money on their children, and the old people would spend the money on food. Our sample size is 33%, so we have to pick 2 people for our survey. Remember, the person doing the survey doesn't know about these groups. So we have an immediate problem. If we only pick 2 people, one of the 3 groups will not be represented. We can ask, what is the chance that both people randomly selected will be in the same group? In other words, 2 young people or 2 old people or 2 middle-aged people. Probability is covered in a different topic, so I will not try to explain how we get this answer, but the answer is the chance is 1 in 10 tries. So what we're saying is that 1 out of every 10 times, both people would be young and choose clothes, or both people would be middle-aged and choose their children, or both people would be old and choose food. Any of these answers is completely wrong and misleading. This is a major problem with random sampling. By definition, the surveyor does not control who will be picked. And that means that occasionally the results will be really weird and not believable. Academics try to solve this problem by what they call controlled sampling. At the start, they recognize that there are 3 groups, so they make sure that there's someone in the sample from every group. In this case, that would mean they had to have at least 3 people in the sample because there are 3 groups. So they make sure there's 1 young person, 1 middle-aged person, and 1 old person. Inside each group, they randomly pick which of the 2 people will be chosen. There are 2 problems with this method. Firstly, they are saying that random can give some weird results, so we will use controlled sampling. But then they are using random to pick who will be chosen from each group. If random gives weird results in one area, why do we believe it won't give weird results in another area? Secondly, because the surveyor is choosing the groups, it is possible that the surveyor's own bias will affect the answers. For example, there will always be other subgroups based on, say, religion or race or gender. In other words, age is only one way to form the total number of people into groups. Suppose each age group has 1 man and 1 woman, and suppose that the men, whatever age they are, always spend half of the extra 100 baht on alcohol. You can see that if you start down the road of trying to control the sample so that all groups are represented, it can quickly get very complicated. It also becomes very likely that 2 different investigators would do it 2 different ways and get different results. And then you have a problem about which one to believe. Another way that investigators try to solve this problem is they do the experiment a lot of times. Let's say they do it 20 times. For the reasons we already looked at, the answers are not all the same. Then they look at the different answers and sort them into a big group of answers that are all very similar and a small group of answers that are a lot different from most answers. Then they ignore the ones that are a lot different. So let's say, for example, they do the survey 20 times. 15 of the answers are similar, but 5 are a lot different. So they ignore the 5 and they conclude that the answer is in the middle of the group of 15. We are saying that the researcher chooses which results they will believe and which they won't. That is a very suspicious way to do research. Remember that scientific method says, firstly, any theory has to fit all the facts. The researcher is not allowed to pick which facts they will accept because they fit the theory and which ones they will reject because they don't fit. Second, the results of the test will be the same every time the experiment is performed. That is also part of scientific theory. So every time you mix hydrogen and oxygen, you will get water. And every time you use the same survey, the results should be similar, allowing for the margin of error. So you should be very wary of research that chooses which results to believe. If someone presents results of their survey, you should always, firstly, use your critical thinking. Secondly, ask how the research was done, and if possible, satisfy yourself about the methods the researcher used. And thirdly, if you are not satisfied about these things, you should not believe the research. And this is the end, my friend. See you next time.